Hello, welcome everybody to our session Divide et Impera, how a fintech company redesign its virtualized infrastructure while preserving workloads uptime. Just a short introduction about who we are. I'm Andrea Perotti, I work for Red Hat since 2012. I'm a platform TAM working and certifying on, among the others, Satellite and Red Hat Virtualization, the enterprise solution based on Catello and oVirt. I've worked on a wide range of oVirt and Rev versions spanning from 3.0 to 4.4. And I live in Milan, Italy. Together with me today, there is also Antonio.
Hey, I'm Antonio Romito. I'm the father of a 6-year-old wonderful girl, and I joined Red Hat almost 3 years ago. I'm also a platform TAM technical account manager, and I'm certified Red Hat engineer with a specialization in Red Hat Virtualization, Satellite, and Ansible. Today, we are here to present an interesting journey to design a solution after some challenging requirements from a strategic TAM customer where we were both involved. We'll talk about the customer and the origin of their use case, their constraints, and the solution we have designed for them.
The scenario we are going to discuss today has happened to a Red Hat customer where both Antonio and I are involved. Their main business is the full infrastructure outsourcing, targeting financial customers. They have various data centers across Europe and rely on Red Hat and open source to deliver the various critical services of their customers. During early 2010, customers adopted for some of their most CPU-intensive workloads KVM as hypervisor of choice, due to its scalability and its better performances. When some years later they migrated from RHEL standalone hypervisor to Red Hat Virtualization, they took the opportunity to consolidate their workloads on more powerful hypervisor, reducing their numbers. Given the small number of hosts, they opted for a simple architecture with a single self-hosted engine to control all the hypervisor across 2 sites and where each site used only its local storage. Rev Manager was their single pane of glass for all their virtualized workloads. But this choice presented soon some limitations. Activating the disaster recovery for Rev platform requires the redeployment of the manager from Data Center 1 to Data Center 2. But they are a small team, the procedure was handled manually. Keep in mind it was designed at the Rev 4.1 era and was never updated to use the oVirt Ansible modules. Also, it's not very straightforward, especially if it has to be done under pressure during a disaster. So not all the team members were skilled enough to do it right at first. Also, redeploying the manager requires an empty hypervisor or to shut down the workloads running of one of them. But none of those options were viable. Customer has a restricted list of models they can buy as hypervisor, and they are all big and costly machines. So having such a big box in cold standby, just in case of disaster, was not acceptable, nor it was shutting down some surviving production VM just to free up some hypervisors. Customer workloads increased during the years, and this architecture was replicated in other regions. But last year, during the planning phase of the migration from Rev 4.3 to Rev 4.4, we discussed and suggested to the customer to address the pain points above with a small redesign. It was agreed that the best way to proceed was to have one manager in each site.
The action plan to split the single Rev environment into one per site was pretty easy. It was necessary to shut down all the VMs in the secondary data center disconnect the storage domains and the hypervisor belonging to data center 2, deploy a new manager in data center 2, and then re-import the storage domain with all the VMs. Unfortunately, as frequently happens in big companies, since those VMs were belonging to different customer business units, it was almost impossible to find an agreement about the maintenance windows, and many were concerned about the loss of 50% of the capacity of their application, despite this was the same scenario as during a disaster recovery.
As Pascal once said, the business has its reasons, which reason knows nothing of.
So now there was a new constraint: split the environment in two while not stopping any VM. So how to deal with these hard requirements of no downtimes for their production workloads during the split operation? How to remove the information about the second data center from the Rev engine running on data center 1 and vice versa while preserving VM regular operation? With those questions in mind, we started analyzing the problem, and we found that the core point was to drop unneeded information from the database while preserving its consistency. We rejected the idea of editing somehow the database. We developed a high-level plan to solve the situation by using Rev Manager itself, and we started writing down the procedure, adding more details after each test iteration on the reproducer of the customer environment we had set up. We identified that the key part of the work procedure was to isolate the manager running on the first data center from the other one, making the first manager believe that hypervisor running in the second data center were gone due to a network outage while keeping the VMs alive. Believe it or not, our idea was to profit from what usually is a nightmare for our customer, a network disruption between two sites. The challenges were to proactively discover and track down any possible issue affecting the VMs still running on those hosts, preserving VM status while splitting the environment. So let's dig into the procedure. Before moving on with the split, it's mandatory to have clear understanding of what is a self-hosted engine. Self-hosted engine is a virtualized environment in which the Rev Manager runs on a virtual machine on some of the hosts managed by that manager. It is controlled by self-hosted engine cluster that is a cluster totally independent from Rev, dedicated to executing the hosted engine. Thanks to the self-hosted engine cluster, manager is highly available. And if the host where it's running as an expected failure, the virtual machine is started automatically on another host part of the same cluster.
To start with the split activity, we need some preparatory steps on the environment. First, we need to identify in Data Center 2 an hypervisor that will be used to install the new manager. Then, we have to completely remove it from the environment. To reduce the live migration of virtual machines in the cluster, the load balancing policy of the clusters in the data center 1 and 2 has to be set to cluster maintenance. Now, we can take a snapshot of the architecture by doing a backup of the Rev Manager. This will be the base for the second manager installation, and will be also useful in case a rollback will be needed. Now we'll start with the procedure to remove Data Center 2 from the manager, all without affecting the existing workloads. In order to avoid any risk for the VMs in Data Center 2, we are going to remove from each host the power management configuration. In this way, host will not be fenceable. Second, we'll stop communication from and to Rev Manager for hosts in Data Center 2. You can achieve that by firewalling the connection on the manager itself or on the firewall between the two data centers. After doing that, the state of the hosts in Data Center 2 will transition from connecting to non-responsive. At this point, Rev is aware that something has happened to those hosts, but is unable to contact them or fence them. So a manual intervention is needed in order to move forward. Our goal, if you recall, is to remove those hosts from the environment, only in the database of course, but this can only happen if there are no VMs running on those hosts. So we have to trick the manager, lying to him. For all hosts in Data Center 2 in non-responsive state, we go and select Confirm host has been rebooted from the menu. By doing so, the manager will receive from the Rev administrator the information that no VM is running anymore on those hypervisors. Now it will be possible to put all the non-responsive Rev hosts in maintenance mode and later remove them, remove templates, cluster, and finally Data Center 2 itself. But in reality, virtual machines will continue to work totally unaware of what is happening. This is because in Rev is the manager that polls the hypervisor for getting information on the workloads and not vice versa. This allows us to shut down the manager with no impact on the workloads. Now that in the manager there is only one data center, we have done half of the job and we can prepare to deploy the second manager on Data Center 2. Since we'll deploy the second manager by restoring the backup taken earlier and the backup contains all the hosts from both data center, and since each hypervisor have to be managed by one and only one manager, otherwise bad things will happen, we'll put the hosted engine cluster in data center 1 in global maintenance and will shut down the manager. In this exact moment, none of the hypervisor is monitored by any manager. Any accident that will happen now will not be addressed. We have to act quickly. Network connectivity between Data Center 1 and Data Center 2 have to be restored. Now, on the hypervisor excluded by the backup, you recall host X, we can deploy the new hosted engine that will manage Data Center 2. We will restore the manager with its original host name, specifying Data Center 2 and related cluster as context for this new manager. We'll change its IP address and will rename using the new host name after the installation. If you take a look at the schema, we have successfully reached the situation specular to the initial one. We have one Rev manager that handles 2 data centers, but now the manager is running on Data Center 2.
Now we are going to repeat the procedure already done in step 1. We are going to remove from each host in the Data Center 1 the power management configuration. Later, we will stop communication from and to Rev Manager for hosts in Data Center 1 to force the state of the hosts in non-responsive. At this point, Rev still knows those hosts, but is unable to contact them or fence them, and manual intervention is needed in order to move forward. We need to remove those hosts from the environment, only in the database, but again, this can only happen if there are no VMs running on those hosts. We apply the trick from the manager again, lying to him, and for all the hosts in Data Center 1 in non-responsive state, we go to select Confirm host has been rebooted from the menu. By doing so, the manager will receive from the Rev administrator the info that no VM is running anymore on those hypervisor, even if it's not true. Now it will be possible to put all the non-responsive hypervisor in maintenance mode and remove them. Remove templates, cluster again, and finally Data Center 1 itself. As before, VMs will continue to work totally unaware of what is happening. All right, the worst is behind us. We still have to restore communication from and to Rev Manager for hosts in Data Center 1, and then remove the global maintenance for the hosted engine cluster in Data Center 1. By doing so, Rev Manager in Data Center 1 will start automatically thanks to the self-hosted engine cluster. And don't forget to set back to the original value the load balancing policy of the clusters in Data Center 1 and 2. Now, every hypervisor is under the control of a Rev Manager in the same data center. Congratulations, guys. You have split your Rev infra with no workload downtime.
So, while customer can sometimes cause big headaches, nobody like end user can bring us real and interesting challenges to overcome. The knowledge of the oVirt components and their behavior has allowed us to force them a little in order to remove unneeded objects from the database without affecting its integrity and without affecting the existing workloads as well. But keep in mind that when we started, we didn't know if our intuition would have been successful or not. This time we have been lucky. Sometimes being brave is to go down a path that may not work, but is worth trying. What we can share with you, if something similar should happen to you, is to write down on paper your procedure and ask earlier for feedback, and then start testing. Repeat and test again. And also to test it in an environment that is as close as possible to the one where you want to apply your procedure. Our experience has been that after all our tests, when we repeated the procedure with the customer in their test environment, we hit a corner case nobody thought about it. Few details about the versions. We have executed this procedure on RHV 4.3. But we have also tested in 4.4. Both versions act in the same way. There is only one small difference during the restore of the backup while installing the second manager. In version 4.3, you have to insert the data center cluster name and host name, while in 4.4, all those information are recovered from the backup itself. That's the only difference. What we have presented today is the outcome of many days and nights spent together installing and splitting Rev, but would not have been possible without the generous help of the community and of our passionate colleagues who listened and supported our crazy idea. Among the others, we'd like to thank our colleagues from consulting who proofread the documentation we wrote, tested it on their labs, and supported the customer while doing the activity, as well as engineering and support teams in Red Hat for their punctual help. We have talked so much for today. It's time for you to speak. Is there any question from the audience? That's all, folks, from us. Thanks for joining today, and happy hacking with oVirt.